Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. There's a lot of really smart people there. Today's puzzle is called Squapple Trees. Squapple trees? Squapple trees, because it's apple, right? Squapple? I'm not sure what the squat is for this, but here are the rules. Oh, sorry, it's by Tinifer too. Here are the rules. Normal Sudoku rules apply, which means every row, column, and 3x3 box contains the full set of the digits 1 through 9. We also have German whispers, where adjacent digits on a green line differ by at least 5. So, for example, if this were a 3, this would have to be an, we would celebrate because if there's a 3 in the corner, and there would have to be an 8 or a 9 in this cell, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how German whisper works. We also have even and odds, where digits in a gray cell are even. So all of these gray cells are even, which means they're 2, 4, 6, or 8. And then finally, we have killer cages, where digits in a cage sum to the given total. So these two digits must sum to 10, and these two digits must sum to 8. So for example, if this were a 2, this would have to be a 6, because those two digits uniquely add up to 8. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so on a German whisper line, you'll always alternate between low digits and high digits, because the digits 1 through 4 can only be next to the digits 6 through 9, right? And vice versa, right? Because if you look at it, 4 can only be next to 9, 3 can only be next to 8 or 9, 2 can only be next to 7, 8, or 9, and 1 can only be next to 6 through 9. So, and next to a digit that is between 1 through 4, you'll always have a digit which is 6 through 9 next to it. Same thing with 6 through 9. 6 can only be next to 1, 7 can only be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1 through 4. So on a digit that has a digit from 6 through 9, you always have a digit that's next to, that has to be in the set from 1 through 4. Because of that, we can just start randomly coloring a German whisper line, and it will naturally resolve itself because you always have to alternate sets on it, right? So we're going to randomly color this yellow, we'll randomly color this orange. These must be orange because it's next to the yellow. This has to be yellow because it's next to an orange set. So this must be yellow. These two are orange because they're next to yellows. This must be yellow, and this must be yellow because they're next to orange. These two must be orange because they're next to a yellow. These two must be yellow because they're next to an orange. These two must be orange because they're next to yellows. And these three must be yellows because they're next to orange. So that's one thing about German whisper lines that I like, is that it's fairly restrictive in that sense. So we have 4 of the same set in column 4. We have 4 yellows, right? Because this is yellow's next to an orange, so it's next to a yellow, which is next to an orange, next to a yellow, next to an orange, next to a yellow. This yellow is next to 1 orange. This yellow is next to 1 unique orange. Actually, we know this orange... Wait, it's not... No, sorry, it's not a square. I thought it was a square. Apologies for that. We can also start coloring this random colors also. So let's make this pink. This is then green, which means it's pink in both of these cells because it's next to a green. This is also pink because it's next to a green. So this must be green because it's next to a pink. These cells must all be pink then because they're all next to green. This is green because it's next to a pink cell. This is pink because it's next to a green. These are both green because they're next to a pink. These are both pink because they're next to a green. This must be green. These two must be green because they're next to pinks, and therefore this is a pink because it's next to a green. What does that mean? Not much right now. Okay. This digit is next to two unique digits on the German whisper line, right? Because these are different digits. So it cannot be 4 or 6 here. This has to be 2 or 8 here. And it's because it's even, right? Because it's in a gray square. This is next to two unique digits, so, but it could be 1, 2, 3, 7, 8, 9. This is not next to two unique digits. We don't know which one that is. But this has to be 1, 2, 3, 7, 8, 9 because it's next to two unique digits. This is next to two unique digits. 1, 2, 3, 7, 8, 9. This cannot be next to a 2 or 8. Sorry, if it's a 4 or 6, it cannot be next to 2 or 8. So this cannot be 4 or 6. So this is also 1, 2, 3, 7, 8, 9. This is next to two unique digits on a German whisper line because these are in the same box. So this is 1, 2, 3, 7, 8, 9. This is next to two unique digits on a German whisper line because they're in the same column. So this is 1, 2, 3, 7, 8, 9. This is not necessarily. This is next to three unique digits on a German whisper line. So it must be 1, 2, 8, or 9. It cannot be 3 or 7 because 3 is only next to two unique digits. Same with 7. This is next to two unique. Yeah, so we're going to look at all the places where there can be next to two unique digits and then make those 1, 2, 3, 7, 8, 9. This is next to two unique digits here. This is next to two unique digits here. This is next to two unique digits here. This is next to three unique digits, so this is 1, 2, 8, or 9. We know in box 1 we have 3 yellow digits. So 3 either lows or 3 highs. The 10 cage has to have one digit that's from 1 through 4, which is a low, and one digit from a high, which is 6 through 9. That means the other remaining digits have to be 5 or orange because they cannot be yellow because one of these has to be a yellow. So we have a yellow and an orange here. This must be 5 with the oranges. So this could be 5 with the oranges. And we don't have any. Okay. I guess these still could be orange both. Okay, so in column 4, we have 4 yellow. So that means it's also 5 with the oranges. So this is also 5 with the oranges. Which means in in row 2, we have 5 cells which must either be 5 or an orange. If the greens were orange also, that would mean there are 7 digits in 7 cells in row 2, which must contain an orange or 5. Actually, we know this has to be 5 and orange because there's only 4 oranges possible, and one of these is a 5. Because of that, we know greens cannot be orange, so greens have to be yellows. The remaining digits actually are all yellow in row 2 because we have 5 cells which must be orange or 5, and that is 5 digits. So these must be all yellow. Pinks then have to be orange. We have 4 orange digits then in row 7 and in row 5. And in column, okay, we know this has to be yellow because it cannot be 5 because one of the 5s is here. So we have 5 yellows and 5 oranges. Sorry, 4 yellows and 4 oranges in column 7, which forces this to be a 5. Because this is guaranteed yellow. This has to be yellow with a 5 possibility. So 5s could be here, here, or here, but the rest are yellow. We don't know about this. This is a 5. We have 4 oranges in row 5, so the rest have to be yellow. So these are guaranteed yellow. We have 4 yellows in box 4, so this must be 5 or orange. We're going to color the ones that could be 5s as pinks instead of just having the 5 by itself. So these could be pink. This could be pink. And this could be pink. These could be pink. This could be pink, pink. Okay. What other restrictions do we have? Not too many. Okay, let's continue with things that can be restricted, right? This is next to 2 unique digits on a German whisper line, so it's 1, 2, 3, 7, 8, 9. This is next to 2 unique digits on a German whisper line, so it's 1, 2, 3, 7, 8, 9. This, actually, none of them could, all of them could be non-unique. So this is next to 2 unique digits, 1, 2, 3, 7, 8, 9. This could be 2, 4, 6, or 8. This is 2, 4, 6, or 8. This is 2, 4, 6, or 8. And this is 2, 4, 6, or 8 here. We have 4 yellows in row 3. So the rest have to be orange or pink. Okay. We have 4 yellows in box 3. So therefore the rest are orange and pink. Well, here in column 8, we have 3 oranges, and these can only be orange or pink. But that's 2 of them. So this one of these must be pink and the other must be orange. That leaves the remaining digits as yellow. So this cannot be pink. This is orange, definitely. And one of these has to be pink. What else do we have? This is pink, so this must be an orange-yellow combination here. That doesn't tell us much. Can this ever be 1, 9? That would force this to be 2, 8, which would be next to a 4 and a 6 here. So no, this can never be 1 and 9 adding up to 10. So this is either 2, 8, 3, 7, or 4, 6 here. What else do we have? Uh, hmm. This is either 1726 or 35 here, but 5 cannot be here, so 3 can't be here. Hmm. What else are we looking for? Hmm. So one of these has to be the 4 or 6 yellow here. Because this can't be 4 or 6. This can't be 4 or 6. So obviously if it's 6, it's 6 is one of those. If it's 4, 4 has to be here. Interesting. This digit has to be exactly the same as that digit. Because if it's not, well, where else could it be in the box, right? This sees those 3 digits, it has to be here. So this is 2, 4, 6, or 8. It's exactly the same. So we'll go and mark it as A, I guess. This is A. Then one of these two was A. Okay, where is this digit in box 5 and box 8? Actually, where is it specifically in column 4? It cannot be either of these cells, so it must be here or it must be here. Well, the only possibility for it to be either of these is 2 or 8, because it cannot be 4 or 6, because 4 or 6 cannot be these two. Right? This is next to 2 unique digits. This is next to 2 unique digits. So either way, it's 2 or 8. So this has to be 2 or 8 here. This is 2 or 8, which means 4 and 6 have to be somewhere here. This can't be the yellow 2 or 8. Could be here, could be here, could be here, could be any of these. But in column 4, it has to be one of these two. Therefore, the 4 or 6 has to be one of these two digits here. And since the yellow 4 or 6 is here, this must be the orange 1 or 9 here to match. This orange 1 or 9 means this can't be the orange 1 or 9, so this has to be the orange 2 and 8 here. Because this orange 1 or 9 is next to a yellow 4 and 6. That's the only digit that can be next to the yellow 4 or 6. So this can't be the orange 1, 9. It has to be the orange 2, 8, which means this cannot be the yellow 4, 6. This has to be the yellow 2, 8. Because the yellow 4 and 6 cannot be next to the orange 2 or 8. Right? 4 cannot be next to 8. 4 and 6 both can't be next to 2 or 8. So this has to be a 2-8 pair, which eliminates 2 and 8 here, and here, and here. This becomes either 3-7 or 4-6. This A actually is here. We know that for certain. So these are all the same digit. A cannot be here. A is one of these two. We're not sure which. So this is 1, 3. Okay, so 4 and 6 cannot be next to the 2 or 8. That's orange. So this has to be 1, 9, and 3, 7 remaining. Which eliminates the yellow 3, 7 from being here. So this must be the yellow 4, 6 and the orange 4, 6 here. The orange 1, 9 cannot be either of these cells. Can't be here. Can't be this. Can't be here. So it can only be here. So this cannot be pink. This is the orange 1, 9. This has to be the orange 3, 7 with a 5, which means this can't be 5. This is pink. This is now the orange 4, 6. So this is 5 here because this can't be 5. So this can't be 5 here. This is now a yellow. We have 4 yellows in column 5, which eliminates yellow in the rest of the column. Therefore, these are orange or pink. This is orange or pink. None of these could be the orange 1, 9. So the orange 1, 9 is one of these. This is the orange 4, 6. This is the yellow 1, 3, 4, 6, 7, 9. We don't know which ones. This can't be the yellow 4, 6, cannot be the yellow 2, 8. It's a yellow 1, 3, 7, or 9, which means this is the yellow 4, 6 here. This yellow 4, 6 is next to the orange 1, 9. That's fine. This cannot be the yellow one. Sorry, the orange 1, 9. It's the orange 2, 3, 7, or 8. So this cannot be yellow 4, 6. It's either yellow 1, 3, 7, or 9 next to the 2, 8, or 3, 7 orange. Okay. Okay. The yellow 2, 8. We don't know. It's either one of these 3. It's one of these 3. We know it's the same as these. Could be one of those 2. Ah, it's one of these 3. So the yellow 2, 8 cannot be here. It has to be one of these 2. So one of these is the A. One of these is the A. One of these is the A. What else do we have? Orange 4, 6. We don't know what this is. This cannot be the orange 4, 6 because it's next to either a 2 and 8 or another 4 and 6. So this has to be 1, 2, 3, 7, 8, or 9. Therefore, one of these 2 digits is a 4 or 6 for orange, which means this must be the corresponding 1, 9 for yellow. So this can't be A. This has to be then the corresponding 2, 8 for yellow, which eliminates 2 and 8 here. So this is the corresponding 1, 9 for yellow, which means this can't be 1, 9. This is 3, 4, 6, or 7 here. That's interesting. This becomes a 3, 4, 6, 7 yellow pair. This is next to 2 unique digits on a German whisper line. So this is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. This could be anything. This is the yellow 1, 9. So this can't be the yellow 1, 9 here. It's a yellow 3, 7. This yellow 3, 7 cannot be next to the orange 3, 7. It's only next to the orange 1, 2, and 8, and 9. So this can't be 1, 2, 8, and 9. This is the yellow orange 4, 3, 7, which is next to the yellow 2-8 and the yellow 1-9. This is the yellow 4-6 then. Sorry, the orange 4-6. This must be then 1, 2, 8, or 9 here. Because this cannot be the orange 4-6. One of these is the yellow 4-6, but we don't know which. And we have the yellow 2-8 here. One of these, again, is the orange 4-6. This can't be the orange 4-6. So it's 1, 2, 3, 7, 8, 9. This cannot be the orange 3-7, because if it's the orange 3-7, it would be next to, at minimum, the yellow 3-7. And the orange 3-7 can only be next to 1, 2, 8, or 9. Same here. This can't be the yellow. This can't be the orange 3-7, because it would be next to, at minimum, a yellow 3-7 here. We have a orange 1, 2, 8, 9 pair in column 8. So this has to be 3, 4, 6, or 7 here. And this must be the orange 3, 4, 6, or 7 with a 5. Okay. This is 1, 2, 8, 9. This has to then be, we have a 1, 2, 8, 9 pair, orange pair in box 3. So this must be 3, 4, 6, or 7. This 1, 9 orange means this can't be 1, 9 orange. So this is 2, 8 orange, which means this is 1, 9 orange here. We have 5 digits, which are orange or pink in row 1. Therefore, the remaining digit is yellow. So this is yellow, and it must be 1, 3, 7, 9 yellow. But that's still pretty broad. This is 3, 4, 5, 6, 7 orange or pink, but it cannot be orange 4, 6. So this is 3, 5, 7 here. This is a This cannot be the orange 4, 6 because we have a double 4, 6 here. We know this is 2, 3, 7, 5, 2, or 8. This, no, we don't know. In box 5, we have a 1, 2, 3, 7, 8, 9 triplet for orange. So either 1, 2, or 3 is here, or 7, 8, and 9 is here, which means the orange in the rest of the box cannot be 1, 2, 3, 7, 9, 8, or 9. So it must be 4, 5, or 6 here. It's either orange 5. Actually, where is orange 4 or 6? Cannot be here, cannot be here, cannot be here. So this has to be the orange 4 or 6 here. So this cannot be pink. This is the orange 4 or 6. That means the orange 4 or 6 has to be one of these two. This yellow is next to a 3 or 7 for orange. So it cannot be 3 or 7 itself. This 2-8 orange yellow means this can't be yellow 2-8. Oh, this is A, so this can't be A here. So this is the A matching this. This 1-9 means this can't be yellow 1-9. This is yellow 3-7, which forces this to be yellow 1-9, which forces this to be yellow 3-7, which means this is yellow 1-9. This orange 3-7 can never be next to the yellow 3-7 because it's not 5 away. 3 is not 5 away from 7. Therefore, this must be the yellow orange 3-7, which means this can't be orange 3-7. This is orange 1, 2, 8, or 9. Either of those work. This can't be the yellow 1-9 because of this yellow 1-9. So this is the yellow 3-7. Therefore, the yellow 3-7 cannot be next to the yellow, so the orange 3-7. So this is orange 1, 2, 8, 9, which leaves the rest of the orange as 3, 4, 5, 6, 7, and this could be 5. But this can't be the orange 3-7, so it could be 4, 5, or 6 here. This is could be 2, 3, 4, 6, 7, 8. So we don't know. One of those is A. This yellow 1-9 cannot be 1-9 here. So this has to be yellow 1-9, which means it's not A, which means the A has to be here. So this is the yellow 2-8 and is A, so this cannot be. This is A, so this can't be A, which means this can't be the yellow 2-8. This has to be the yellow 4-6, so this can't be yellow 4-6 here. This is yellow 3-7. This is the only other place for the yellow A, so this has to be 2 and 8. That means the yellow 4 and 6 has to be one of these two. This must be, this yellow 3-7 eliminates the yellow 3-7 here, so this is the yellow 4-6. One of these is yellow with pink. And one of them is yellow with pink. It's 4, 5, and 6. So one of these is pink, which means this cannot be pink here. This is then a 2, 3, 7, or 8. We're not sure which. One of these is a 5. It's with 1, 2, 8, or 9. For the orange. We're not sure which. The 1 or 9. Where is the yellow 1 or 9 in row 7? Can't be any of these because of this 1 or 9. Can't be here because of this 1 or 9. Can't be this one, so it must be here. So this must be the yellow 1 and 9. This is the yellow 4-6, which means this can't be the yellow 4-6. This is the orange 4-6, which means this can't be the orange 4-6. This is the yellow 4-6. This can't be the yellow orange 4-6 here, so this is 3, 5, or 7. But either of these could be the orange 4-6 here. This is yellow 3-7. That can only be next to orange 1, 2, 8, or 9. We have a 2, 1 orange 1, 2, 8, or 9. So we know the last orange has to be the orange 4-6. Okay. We have 4 yellows now in column 2, which means the rest are orange or pink. This orange 1-9 means this can't be the orange 1-9 here. This is the orange 2-8. This orange 4, 6 means this can't be the orange 4, 6, so this must be the 5. Which means this can't be 5, this can't be 5, this has to be 5 here, this can't be 5 here, this can't be 5 here, this is the orange 3, 7, which means this can't be orange 3, 7, this is orange 4, 6. This 5 means this can't be 5, so this must be the 5 here. That leaves the orange 1, 9 in row 6, which means this can't be the orange 1, 9. It's the orange 2, 8. Orange 2, 8 cannot be next to 4 or 6. So this is 3 or 7. This orange 2, 8 eliminates orange 2, 8 here. So this is orange 1, 9, which eliminates orange 1, 9 here. So this is orange 2, 8. This orange 2, 8 eliminates orange 2, 8 in the rest of the row. This can't be 2, 8. This can't be 2, 8. This can't be 4, 6 because of this orange 4, 6. We've eliminated orange 3, 7 here, so this has to be 5. It cannot be the orange. This can't be pink, and it can't be orange 3, 7, so this is orange 4, 6, which makes this orange 3, 7. This orange 3, 7 means this can't be orange 3, 7 here. This is a 5, so this can't be 5. This is orange 2, 3, 7, or 8. 2, 3, 7, or 8. This orange 2, 8 eliminates orange 2, 8 here, so it's orange 3, 7, which eliminates orange 3, 7 here, so it's orange 2, 8. This orange 2, 8 eliminates orange 2, 8 here, so it's orange 3, 7 here. This is orange 2, 8 with 5, and we're not sure which. This is 5, so this cannot be pink. This must be a yellow. So it's orange 3, 7. This can't be yellow then. This is 5. That eliminates 5 and 3 as a possibility for this pair. This is yellow, definitely, so it must be with an orange. So this is orange here. It cannot be 6 here, so this can't be 2, right? Because the orange 4, 6 is already here. The orange 7, 3, 7 is also here, so this can't be 7. So this is orange 1 or 2, which means all the oranges are low. And all the yellows are red. So this must be this one of these is a 6. This is a 1. So this must be 2, which makes this a 6, which makes this a 1. So this is 2. Remove the reds. All of these are 3. That's 3 in the corner. This can't be 2. This can't be 2. So this must be the 2 here. All the 2 8s, non-red, are 2. So these are 2. Except not this one. This is 8. This can't be 6. Can't be 4. The only digit remaining is an 8 here for this red. This is red then, and is a 7. All the 4, 6 lows without red are 4s. This has to be 5 and is pink. All the 1, 9 non-reds are 1. Okay. This cannot be, so this has to be the 7, which forces this to be the 6. This has to be 9, and this is 8. So we should be able to get all the 1 9s, that's 9. All the 2 8s are 8. All the remaining 3 7s are 7. Oops. All the remaining 4 6s are 6s. Okay. So this is yellow, sorry, this is green, blue, I can't speak. This is blue and pink left. This can't be pink, so this must be pink here. And this is a 5. That remains this as a 1. This has to be 1 and 7. So this is the low and a 1, and this is the high and the 7. So this is 7, this is 1. Remaining digits here are 4 and 8. 4 cannot be here, so this is the high. This is the low. How about here? This is 3 and 6. This can't be the low. This has to be high. This is low. So this is 4, 3, 6, and 8. Oh, and this digit. This is a high and is a 6. That's how you solve it. Yeah, pretty interesting use of German whisper lines. Yeah, just German whisper lines, right? And the odd even cages, right? Because that restricted things in certain areas, right? Also. But it's basically just the German whisper trees, essentially, which limited things in where things could be, right? So, very cool use of that. Yeah, and I hope you had an enjoyable solve. And I'll see you next time on Frank Puzzles. Take care.